Hey, so today we're looking at doing the area between graphs, okay? So what you're going to be doing is you're going to be given two functions, one that's kind of like in the top and then another one that's in the bottom, and then they'll form some sort of region and you'll have to figure out the area between them. They may intersect, and form some kind of closed region, or some other side of it might be kind of left open, but you'll still be given some kind of boundary there, all right? So if we kind of look at the graphs that I've got here on the screen, it's like the upper function, you've got some lower function, and here's your area A, okay? Now, in order to get this done, you're going to be able to employ the integral, the thing you've been working on for quite a long time now. And so you've got your two, well, let's look at this formula. The area is integral from A to B, so the A indicates the start of the region and the end of the region. And the integrand, which is this part in the middle here, is going to be sort of the distance or the height of each one of these boxes. Now, in order to figure out the height of one of those boxes, right, what you're basically looking at trying to do here is figure, okay, well, here's G, all right, G of X. That's the height of the lower portion of that box. And then F of X, I'll make a blue one here, F of X is going to be sort of like from here to here all the way. And if you do the difference between those by basically taking the blue line and subtracting the red line from it, you're left with the height of that box. So as a result, this is basically your overall formula that you're going to end up using every time, all right? Now, the one thing you're going to want to do is graph these functions so that you know which one is which one is the top function and which one is the bottom function, all right? But fortunately, they usually tend to give you, for these questions, some pretty easy functions to graph, all right? So let's go ahead and start with this example here. I've already graphed it, actually. Oh, let me stop or go back. So there's our example. Find the area of a region bounded by the graphs of the given equations. So here's our equations. And we're going to partition the x-axis. So what that means is our little rectangles are going to be partitioned along the x-axis there. And we want to present the exact answer. Okay, so basically our one function is y equals x. Okay, so pretty classic function. Thanks for giving us a pretty easy one there. So y equals x. Y equals 2x, so that's again also pretty easy, which is just going to be that function there. All right, and then x equals 1, which is this function right there. As you can kind of see, if you've done that all correctly, it forms an area, all right? And there's our area right there. And now our goal is to take this area formula, all right, and say that, all right, this is from A to B. Well, A is the beginning of our region, and B is sort of the end of our region. So it looks like our region starts at 0 and it ends at 1, okay? Because remember, this is x equals 1. X equals 2, and so forth, okay? So it goes from 0 to 1. And then my above graph, f of x, that's going to be the graph that's sort of the tallest one. So it's just going to be this guy. And if you recall, this is y equals 2x. And then, so that's going to be my above graph, or 2x. Now, I would subtract the g of x, which would be the lower graph. And that was, if you recall, this is y equals x. So I'm just going to subtract x, and then I'm going to get a dx there. Okay? And that's it. It's about as simple as it gets. This one is, at least. All right? Ooh, I don't know what happened there. Okay, we'll get rid of that. So our area is from 0 to 1. 2x minus x is just going to be an x. Oh my, that is as simple as it gets. And so basically, I'm going to integrate from 0 to 1 the function x, okay? And so my integral is going to be, I think if you're familiar with this notation, I'm going to go like this. So the integral of x is going to be x squared over 2. And I'll evaluate it at 1, and then I'll subtract it evaluated at 0. So 1 squared over 2 minus 0 squared over 2, right? So this is just your traditional classic integral, right? So bang, it looks like we're going to get a 1/2. So apparently this red area over here has an area of about a half. Not even about a half. It should be exactly a half. All right? So there, that was a pretty easy one to start with, right? So let's spice things up a bit. Let's take this one here, okay? This one is a bit different, and I'll tell you how this one is different, because what's gonna happen is part of our function is gonna be below the x-axis, and the other part is gonna be above the x-axis. So let's again start by graphing. So find the area of the region bounded by the x-axis, okay? So the x-axis, that's one of our things that's bounding our function. And this function, x squared minus 4 is going to be, let's see, I guess it's going to go something like this. It's a parabola, okay? And these values, by the way, are going to be 2 and 2, negative 2, all right? And x equals 0 is the other one. Oh, that's the y-axis. Okay, so there. All right. Interesting. And let's see. Where are we going with here? X equals 3. X equals 3. So I guess I'll put that there. And I'm going to do something along these lines. All right. And so what we're going to do is we're going to take... We've got a pretty big area. We've got two. It looks like we've got two areas here. All right. This one. All right. Oh no. Actually, it's x equals 0. So we're stopping here, and we're going to x equals 3. So from 0 to 3. So it looks like we do have two areas. There's one, and there's the other. Okay. And we've got an area over here, but it appears that that area is not valid because it kind of gave us x equals 0 and x equals 3, kind of meaning that this area over here is not really part of the game. All right. So since I've got two areas, what I'm going to do is I'm actually going to break this up into two integrals. All right. Dx, and I'm going to add them up. All right. I'm going to add them up. Hopefully I've given myself enough space there. And basically, I've got to figure out, okay, I'll do this first, this one first. This goes from 0 to 2. You see how it goes from 0 to 2? So I'm going to go from 0 to 2. This one goes from 2 to 3. So I'm going to go from 2 to 3. And now we're going to use our regular, so the upper function minus the lower function. Well, what is the equation of this function? This is y equals 0. So it's 0 minus the lower function. This lower function is x squared minus 4. So x squared minus 4. Okay? And now, for this one, my upper function is, in this case, is x squared minus 4. And my lower function is 0. So we've switched. We've switched games. Here my upper function is the x-axis, and here over on this area my lower function is the x-axis. And so that's why this 0 goes over here in this case, and it's over here in this case. And now if you look closely here, we've got just a pretty solid basic integral. And I'll cut straight to the chase, and I'm going to integrate these guys. So this is from 0 to 2, right? And I'm going to get a negative x to the 3 over 3, and I'm going to get a plus 4x. This is going to be my integral. Notice my negative 4 becomes a positive 4, and then I integrate 4 into 4x. Plus, from 2 to 3, whoops, sorry about that. We're going to go like this. I'm going to integrate this, x squared minus 4 minus 0. I can kind of forget about that 0. So this is just going to be an x to the 3rd over 3 minus 4x. And I'll integrate this from 2 to 3. From 2 to 3. Okay? And now, that's pretty much it. Now we just have some pretty simple integrals. I'm going to evaluate this at 2. Then I'll subtract it, evaluate it at 3. So a negative 2 to the 3rd over 3 plus 4 times evaluating it at 2 minus it evaluated at 0, okay, plus 4 times 0. Then I'm going to add this addition sign is here. And now I'm going to evaluate this at 3, and then I'm going to subtract it, evaluate it at 2. Okay, so 3 to the third over 3 minus 4 times 3. And then I'm going to get, I'm probably going to run out of space, so let me do something like this. A 2 to the third over 3 minus 4 times 2. Okay, so I evaluated at 2, which is this, evaluated at 0, parentheses, then evaluated at 3, and then again at 2. All right, and as you kind of simplify all of this stuff, I kind of did this one beforehand because I'm almost sure I was going to make a mistake. It's a negative 8 over 3 plus 8 minus all this stuff is 0 plus 9, right? Because this is 27 over 3, which is 9, minus 12 minus 8 over 3 minus, or plus, actually, 8, because this negative becomes an 8. When you do all of this, your numbers become 8, 12, 9. Looks like we're going to end up with a 15. Minus 8 and an 8 is a 16 over 3. And that's pretty much what we've got. Common denominator is going to give me 45 over 3. 45 minus 16 is 29 over 3. Okay, so it looks like my area is 29 over 3. So what you want to do is just observe that formula. Make sure your above function is here and your below function is here. Remember that the x-axis it is a function, and it's a 0. Its function is 0. All right. Let's see here. Let's keep going. We got another example. Oh, what about partitioning the y-axis? Here we go. As it turns out, you can actually also have your functions in the y direction here. So rather than having your rectangles run vertically like before, you can have your rectangles run horizontally like this. So for this one, it's going to be convenient for us. And this says, find the area bounded by these graphs. And it doesn't actually tell you this, right, to begin with. So, but let's graph these two functions right away, real fast. And you're going to notice, oops, you're going to notice that here's my y squared equals x. This is basically the square root of x function. And then here's y equals x minus 2. X minus 2, it's got a y-intercept of negative 2. And it's going to go something, this is going to have to go a little bit further. It's going to go something like this. All right. So if you look closely, I've got an area. Now, if I were to make my partitions like this, okay, then I've got a bit of a strange thing because I've got an upper function. I'd have to sort of break this into two different areas, because here I've got two different upper functions. I've got an upper function and a lower function. And then here I've got a different upper function and a lower function. So if you notice that, then instead what you actually can do is say, oh look, I'm going to break my partitions into the y direction, because now look, if you look at it like this, I'm going to move my head like this. These here, this is my upper function, and then down here is my lower function. So now if you look closely, I actually have just a single upper function and a single lower function, and so I can make a single derivative. I said derivative, I meant integral. And since our boxes or our rectangles are horizontal like this, we can make dy rather than dx. So, because notice, when you have horizontal rectangles, then your infinitesimal here is a dy, because remember, the width of each one of these rectangles is some sort of y amount. All right. So now the question is, where do these guys intersect? Okay, this is 4, 3 over here. Sorry, that's 2. That's a 2. And this one down here is 1 comma negative 1, okay? And so therefore, our limits of integration here, our upper and lower bound, are going to be from, negative 1 to 2, because we're integrating in the y direction. So remember, I'm kind of turning my head here. So we're integrating in the y direction here, okay? And so we're going from negative 1 to 2, right? And now I'm just going to use the same. So I'm going to take my upper function, and I'm going to divide it, subtract my lower function here, okay? Well, my upper function is this, y minus plus 2 equals x. So it's y plus 2. That's my upper function. That's this one. And then my lower function is going to be this one here, which is, in this case, y squared. Okay? Now you might be saying, wait a minute, why are y's here instead of x's? Remember, when you're doing dy, you want all your functions here in terms of y rather than x. Okay? And so now, if you look closely here, you've got a pretty solid integral that's very simple. And I'll just kind of fly through this one here. And we're going to get a y squared over 2 plus 2y minus y to the third over 3. And when you evaluate this, you get some kind of area there. And I'll stop there. So basically, we've got 3 different variations there. A simple one where you've got all the action happening in one side of the, or sort of above the x-axis. Here's one where you've got 2 areas sort of broken above and below. And then here's one where you have to break your area in a volume, or sort of in a horizontal manner, okay? So here, actually, go ahead and type this into a browser, and I've prepared like a little lesson that'll help you go through some of these, okay? So there you go. Enjoy.